let's do the first three because I'm bored. Not because I'm angry or anything. I'm just bored and I would like to talk a little bit. And then I'll shut up if I need to, if people need some more time. So let's do these first three. Eric, in honor of you being back, I will let you choose the ink color today. 3. Which green? Dark or light?
Light.
Light green it is. Even though this is all in dark green. Whatever. Okay. So, what do I need to do to that radicand? I need to break it down into factors. Now, if you're really good at this, then there's a shortcut to breaking down the radicands. To be good at it, you need to know your perfect squares and cubes. Using this one, since this is a square root, I would want to use perfect squares, yes? Now, I know that that ends in 8, so I know it divides by 2, yes? But 2 is not a perfect square. So, the next perfect square is 4. Since it divides by 2, let's give 4 a shot. 4, ooh, that's too thick. 4 goes into this how many times? 37 times. Now, I can stop there. Why? Because 37 is a prime number. It has no other factors. And 4 is a perfect square. What is the square root of 4? 2. So what's coming out here? 2. What's already out there? So what do I do there? Multiply. 6 root 37. And that's going to be really ugly when it shows up because I started writing 47. There we go. Yeah? Yeah. What's different in number 2? It's a cube root. But does what I do change? No, not till the end. If I'm good, I can stop in one step. What is the one step that I could stop at? 8 times 10. Why? Because 8's a cube. What if you don't know that? And I know some of you don't know that because when I do this and say I'm stopping here, you get that kind of glazed look in your eyes like, what the hell is he talking about? And that's okay. Because you don't have to stop there. That's only a shortcut. You could continue to break that down. 2 and 4, 2 and 2, 2 and 5. And there is your group of 3. So what comes out? 2. What do you do with those numbers? Multiply 10 cube root. And what'd you leave under there? 2 times 5, which is 10. Okay? Okay. Now, number 3. Number 3 has both letters, variables, and a number. If there were no variables there, would you know what to do with 108? Yes, you would break it down and look for groups of 3. Since 108 is 27 times 4, I can stop there, can't I? Yeah. Why? Which is what? 3. So out will come a 3. Yes? What will stay under there? The 4. Now, letters are no different. A cubed means what?
A number cubed.
A number. A cubed. So there's 3 of them. Is that a group of 3?
Yeah.
So what comes out?
A.
Just an A. Right? How many B's are in there? Careful, you might get stung. B's. Bzz. Oh, I see.
That's what I heard too.
Okay. My poor enunciation ruined my own joke.
Yeah.
B, 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 B. Can you get a group of 3 out of there?
Yes.
Right. How many groups of 3? 1. So out comes a B, and what stayed under there? BB. But we would never write BB, would we? No. Because we're math people, and math people would write B squared. What do I do with the 3 and 7? Multiply them to get 21. 21 AB cube root 4B squared. Because you can only get out 1B. Everybody cool? Is everybody good?
Hold on.
I am holding on. Are we good?
Sure.
Okay. Are people done with the second row?
No.
Okay. Let me remind you, if you don't remember, the way I showed you to learn how to do these was I said it's the same as 3x times 8y, right? The 3 and the 8 go together, and the x and the y go together. So in this case, the 3 and the 8 will go together, and the radicands will go together. Except there's a problem. What is it? No, multiplying is okay. 27 times 45 is what? A gigantic number. Who would want to simplify that gigantic number? Crazy people, especially when you can simplify these simple ones. Simplify every chance you get, not just at the end. Go. I will have a sip of my tasty beverage. And now I am out of tasty hot beverage, and I am moving on to taste less cold beverage. I will be going back to light green because yellow is hard for me to see on the screen. It comes up much better up there, though. I just said that. I could make a custom color.
Blue and green. What? Do teal. Yellow and blue. No. Yeah.
Let's talk about this one. Simplify every chance I get. Can I simplify here?
Yes.
What would it be? 9 times 3. What do you do with that 9? Bring out the 3. So what do I got? 9 root 3. Yeah? What about this one? 9 times 5. What do I do with that? Bring it out. What's 3 times 8? 24 root 5. Now it's super easy. 9 times 24. What's 9 times 20? What's 9 times 2? 18. Add a 0. 180. What's 9 times 4?
36.
What's 180 plus 36?
216.
216 root 3 times 5. 15. Done. Simplify every chance you get. Why aren't I simplifying that? 216 is a big number. Because you never simplify the coefficients, and 15 doesn't have a pair, does it? It's 3 times 5. Doesn't have a pair. What should you do with number 2 here? Simplify every chance you get. Can you simplify here? 2 root 6 simplifies? No. Because 6 is 2 times 3. Does this simplify? To what? Isn't that 36 times 2?
Sure.
Okay. What's the square root of 36? 6. So 6 comes out. What's 6 times 2? 12 root, what did I leave under there? 2. What's 8 simplify to? 2 and 4, right? What do I do with the 4? It comes out here. What do I get? 6. Hey, wait a minute. I got 12 root 2's and 6 root 2's. How many root 2's do I have? I got 12 of them there and 6 of them there. I got me 18 root 2's. Now, this is super easy to multiply, right? What's 2 times 18? 36. Root, what's 2 times 6? 12. Would I stop there? course not. Why? Because 12 is 4 times 3, yeah? So what comes out? 2. What's 2 times 36? 2 times 36, it's right there. 72 root, what did I leave under there? 3. Done. Yeah? Yeah. Now, last 3. This is what we did yesterday. If you weren't here yesterday, you're going to have a little bit of trouble with this. If you didn't watch the video. But those of you who were here yesterday should have no trouble with this.
I started watching the video.
What happens to the 5? Becomes the index. What happens to the 32? It's the radicand. And what does the 2 end up doing? Squaring the whole thing. So now I need the 5th root of 32. I already have that memorized. It's 2. Because I have memorized 2 up till 2 to the 10th. Because it's helpful for math. But if you didn't have it memorized, all you do is break it down and find out that there's a group of 5 there. 2 times 2 times 2 times 2 times 2 is 32. So that is 2 squared. What's the answer? 4. Done like dinner. What about this one? What do you see here? Exponents that are going over a bracket. One of them's a fraction, so you're scared. But you shouldn't be, because if I gave you this question, x squared cubed, what would you do with those 2 exponents? Multiply them. So what are you going to do here? Multiply them. What's 1/3 times 2? 2/3. 512 to the 2/3. Now, does 512 to the 2/3 look a lot like 32 to the 2/5? It's a base with a fraction exponent, yeah? Do we know what to do with fraction exponents? Spent a whole lesson learning it yesterday. And we just did one here. What happens to that 3? Becomes the index. What happens to the base? Radicand. 512. All to what power? 2. I know what the cube root of 512 is because I've memorized the first 10 perfect cubes. So I would be done here. But some of you wouldn't be. You would have to break that 512 down. And you would find out that that is 8. To what power? What is 8 squared? 64. And you'd be done. And finally, this looks scary, but it isn't. Why? Because, again, if I gave you this, x squared times x cubed, which will show up in a minute, what would you do with those exponents? You would add them, right? Because I have the same base and they are multiplying, correct? Okay, so what's happening right there? No. What math is happening between multiply? And is that and that the same base?
Yeah.
So what are you going to do with 3 halves and 2? Add them. 16. And you're going to add 3 over 2 plus 2. But you can't add 3 over 2 to 2, can you? Because that's really 2 over 1, isn't it? And what do you need to add fractions? Same denominator, which would be what? 2. Did that one change? So did that one change? No. Did that one change? How? Times 2. So what does that one do? Times 2. So that's 4. What is 3 plus 4? 7. So now I have 16 to the 7 halves. Does that look exactly like that? Look exactly like the last one?
Yes.
Yes, it does. What happens with the denominator? Goes to the index. So I'm looking for a square root of what? 16. To what power? 7. What is the square root of 16? 4 to the 7th power. Do you know that in your head? I don't. So where do you go? Calculator. 4, exponent button, 7. And then you tell me the answer. But you do not read me the 5 digits. You tell me the number. 16,384. Now, why do you finish that off, but you leave this as x to the 5th? Because x is a variable and you don't know what it is. If you ever have an integer here and an integer there, you evaluate it. Does everybody understand? Is everybody cool? All right, now listen to me and listen to me closely, please. The pages that you are going to do are 108, 109, and 110. That is the bare minimum that I expect to have done by tomorrow. All right? There is extra practice there on the next 2 pages. I know that none of you or very few of you do that extra practice. That is fine. But again, I remind you, do not complain or cry about your grades if you are not going to practice. You have been provided with practice. Use it. If you choose not to, just like every other choice you will ever make in your life, there is a consequence. And 99 times out of 100, the consequence of not practicing is not doing well when you play. When is the playing in a classroom? Assignments and tests. Okay? So again, if you choose not to do the practice, then expect a consequence. Just like the rest of your life. If you choose to sleep in and not go to work, expect to get fired. If you choose to eat 7 pizzas a day, expect to die at 40. Fat. Okay? Everything in your life is your choice. Make good choices, you will be just fine. If you make a bad choice, accept the consequence and try to work with it. Huckly dokley? Huckly dokley. Now, the next thing I would like to talk about, though, is this. The first instruction on page 108 says, without a calculator. Here is what I mean by that. I'm going to call your attention back to this question right here. Once we got to here, we didn't use a calculator to get to there, did we? And then we had to multiply 9 times 24. That type of thing, go ahead and use your calculator for. Do you understand what I'm saying? The work that we did was fine. What I'm saying when I say don't use a calculator is I don't want you to do this. 3 times square root 27, which gets you something like 16.1375 endless decimal. And then multiply that by 8 times square root 45, which is around 8 times 6.5, around 54. And then give me an endless decimal. That's what I don't want you to do when I say don't use a calculator. Does everybody understand what the difference? Okay? Do all the simplifying without a calculator. But if you got to use it to do like, you get a giant number like 72 times 85 here, go ahead and use your calculator for that. Everybody with me? Okay. I'm going to shut up and remind you once again. Oh, before I go too much further, how was everybody, if anybody did it, page 106? Did anybody want to talk about anything on 106? I'll get to that in a sec. I just want to make sure. Does anybody need to talk about anything on page 106? Anybody? Okay. So I'm assuming everybody is good. You are doing right now, you're starting on page 108. And you are working at least till page 110. You're finishing 110. That's the bare minimum. If you want the A, you would look at page 111 and page 112, because there's a crap ton more practice there. Do you have to do it all? No, you never ever do. But if you want the A, you practice enough to get the A. Right? But I expect 108, 109, and 110 to be done for tomorrow. Hockley dockley? Hockley dockley. Now, let me give you a couple of pieces of advice. Right away, everybody jumps to number 2 and says, oh my God, that's utterly frightening. Except it isn't. Use your brains. What do you notice about that and that? They're the same, aren't they? So isn't that question exactly the same as x and x? Isn't that exactly the same as x to the negative 4 to the 2 times x squared to the 3? And what would you do there and there? Right? Use your brains. There is nothing here you don't know how to do. Same with down here. Everybody sees fractions like, oh my God, I don't know what to do. Well, if that was 7 squared over 7 to the 3rd times 7 to the 5th, what would you do with the 3 and the 5? Add. So what would you do with 1/3 and 5/3? Add. What would you do with the 2 and that 8 when you did this question? You would subtract. So what are you going to do with 2/3 and that? Subtract. Just because it looks weird doesn't mean the rules change, right? If I came in here wearing my surfing wetsuit and began to teach you math, would anything change for you? No, because you would still be sitting there not doing math. Just kidding. You guys are a good class. But I would look different, just like this looks different, even though it's the same math. Go.